sklearn, cluster, compute optics graph. Description. This function computes the optics ordering points to identify the clustering structure graph for a given dataset. Optics is a density-based clustering algorithm that finds clusters of varying densities and handles noise points effectively. Inputs. X. This is the input dataset, represented as a 2D NumPy array. Each row corresponds to a data point, and each column represents a feature. Min-samples. This parameter specifies the minimum number of samples required to form a cluster. It determines the minimum density required for a region to be considered a cluster. Outputs. Reachability plot. A 2D NumPy array representing the reachability plot. Each row corresponds to a data point, and each column represents the reachability distance to the corresponding data point. The reachability plot provides insights into the cluster structure and density of the data. Predecessors. A 1D NumPy array containing the predecessor indices for each data point. The predecessor index for a data point refers to the index of the point that led to its inclusion in the cluster. Ordering. A 1D NumPy array containing the ordering of data points is determined by the optics algorithm. This ordering reflects the density-based structure of the data. Steps. The optics algorithm initializes by selecting a random data point as the starting point. It then computes the reachability distances from this point to all other points. The algorithm then proceeds by selecting the next point with the minimum reachability distance, and repeats the process. The algorithm continues iteratively until all data points have been processed. The reachability plot, predecessors, and ordering are generated based on the computed reachability distances. Metrics. Reachability distance measures the distance from a given point to its closest point that is already part of the cluster. Coordistance measures the distance from a point to its kth nearest neighbor, where k is the min-samples parameter. Visualization plots. Reachability plot. A visualization of the reachability distances, highlighting the cluster structure and density variations. Cluster dendrogram. A hierarchical representation of the clusters identified by optics, providing insights into the nested structure of clusters. Fine-tune parameters. Min-samples. This parameter allows you to control the sensitivity of the algorithm to cluster density. Lower values result in more sensitive detection of clusters with lower densities, while higher values may lead to the merging of smaller clusters. Metric. This parameter specifies the distance metric used to compute the reachability distances. You can choose from various metrics like Euclidean distance, Manhattan distance, etc., depending on the nature of your data. Uncertainty methods. Sensitivity analysis. Varying the min-samples parameter and observing the changes in the cluster structure and density. This helps assess the robustness of the results. Ensemble methods. Running multiple optics instances with different random seeds or parameter settings and analyzing the consistency of the identified clusters. Challenges and fixes. Challenge 1. High dimensionality can lead to difficulties in computing distances accurately, potentially affecting the quality of the cluster structure. Sample use case. Working with a dataset containing a large number of features. Fixes. Feature selection. Reducing the number of features by selecting the most relevant ones for clustering. Dimensionality reduction techniques. Applying techniques like principal component analysis (PCA) to reduce the dimensionality of the data while preserving the important information. Challenge 2. Choosing the optimal min-samples parameter can be challenging and requires careful tuning. Sample use case. Running optics with a value of min-samples that is too low might lead to over-segmentation. while a value that is too high might miss subtle clusters. Fixes. Experimentation running optics with different min samples values and observing the resulting cluster structures. Visualization using the reachability plot to identify the appropriate range of min samples values that best capture the cluster structure.